Ladies and gentlemen, welcome to lecture number 3. Today we will discuss the stress transformation concepts and then we will discuss a problem related to stress transformation. So let's start without wasting any further time. This is the problem we have selected to discuss. But before discussing this problem, we will see some concepts. Let's consider an element, 3D element. This is a 3D element. And axis corresponding to that element is x-axis, y-axis and z-axis. So stresses on x-plane in x direction is represented as sigma x, sigma xx. Here the first x means on x-plane and second x means in x direction. Again, this plane, upper plane, is a y plane. So stress on y plane in y direction is represented as sigma yy. Similarly, stress on z plane will be represented as sigma zz. These all three are normal stresses because these are acting normal to that plane. Now we will show the shear stress. The shear stress on x plane in y direction. This is the x plane and direction is y direction. This is represented as tau xy. Here first letter means on which plane and second means it denotes the direction. Similarly, this is known as tau xz, and hence we can write all the stresses in all 6 planes. We will show this is tau z x, tau z y. Again, this is known as the tau y x, and this is tau y z. Now if we consider only xy plane, means this plane, and we are writing separately, this is the plane xy. We are converting from 3D stress system to 2D stress system. If the stress is plane stress, what does the plane stress mean? It means the stresses across the thickness, these stresses across the thickness should be uniform and constant. So this 3D system can be converted into 2D system like this. This is the xy plane. Sigma x is the stresses in x direction. Sigma yy is the normal stress on y plane in y direction. These two are the complementary stresses. Again, we have to also denote that shear stress like this. This is known as the shear stress tau xy. So we have converted 3D stress system into 2D stress system only if the shear stress tau zy, tau zx, these are 0 and only sigma xx, sigma yy and tau xy are present. So this is our required stress system. Sigma xx is sometimes represented as sigma x in 2D system. Sigma yy we write simply sigma y in 2D system. These stresses are given with respect to x and y axis. So if somebody asks what is the stress at some angle, if this is the plane, this was our sigma x, and if we rotate this plane by some amount theta, let's say this angle is theta, then what will be the stresses, normal stress on this plane, that let's say it is sigma x dash, and what will be the shear stress on this plane, tau xy dash, and again sigma y dash and tau xy dash. Basically we have to find out sigma x dash, sigma y dash and tau xy on a plane which is at an angle theta, and then we will find the resultant on this plane. What will be the resultant? We simply translate the vector tau xy here, tau xy dash, and this is the resultant. We are denoting it as sigma r dash, and this angle alpha is the angle between the resultant vector, resultant stress, and the normal stress on the plane which is at an angle theta. Now we have some formula to calculate sigma x dash, sigma y dash and tau xy. So let's see the formula. Sigma x dash is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. Tau xy dash is equal to minus sigma x minus sigma y by 2 sin 2 theta plus tau xy cos 2 theta. And there is one property of this stress system, and that is sigma x plus sigma y is equal to sigma x dash plus sigma y dash. So using this property we can find sigma y dash, and it will be equal to sigma x plus sigma y minus sigma x dash. So if we have calculated sigma x dash, then we will put the value of sigma x dash in this equation 1. Now what will be the resultant stress? Sigma r dash, it will be equal to root under sigma x dash square plus tau xy square. And what is this angle alpha? This angle alpha will be equal to tan inverse tau xy dash divided by sigma x dash. So using this formula we can solve all the problems of stress transformation. Remember, we have to remember only two formula, that is the sigma x and sigma y, tau xy. And using this formula we can derive the result of sigma y dash, and then we can calculate resultant stress and angle alpha. So let's go to the problem. Please read this problem. Let's solve first. We have element an element, and we have a stress sigma x. Please note that sigma x is given tensile, so we'll give arrow outward the element, and 60 MPa. These all are stresses at perpendicular. This is the sigma y given. Sigma x is equal to, here we are writing here, sigma x is equal to 100, sigma y is equal to 60. In case of third A, and they have asked to calculate the normal stress, that is equal to sigma x dash, the tangential stress, that is equal to sigma tau xy dash on a plane inclined at 30 degree. Here theta is equal to 30 degree to the plane of this 100 MPa stress. Also find out the resultant. We have to find the sigma r dash and its inclination, means alpha. So in third A, what are the given quantities? Theta given, and sigma x and sigma y given. So first we'll write all the given quantities, then we'll put the value of given quantity in the formula that we have derived. So let's write the given value. Sigma x is equal to 100, sigma y is equal to 60, theta is equal to 30 degree, and we have to find out sigma x dash, sigma y dash, tau xy dash, sigma r dash, and alpha. In question number 3b, sigma x is tensile, so we write 100 MPa, and sigma y is the compressive. Please note sigma y is a compressive stress, so we will write sigma y is equal to minus 60. This is very important, and we have to find out all the required answers. In case of 3c, both stresses, one stress is compressive and other is tensile, so sigma x will be equal to minus 100 MPa, and sigma y is tensile, so we'll write plus 60 MPa and calculate all other stresses. And in 3D, both given stresses are compressive, so sigma x is also negative and sigma y will also be negative, minus 60. Now we will put all given values in the equation we have derived. So I have done this for you. For first case 3a, all sigma x, sigma y, tau xy is given. Tau xy is 0, so we'll put in that equation and we are getting this result. And this is the sigma x dash is equal to 90 for first case. This is the tau xy dash, and this is the sigma r dash, this value. And what is the value of alpha here? Alpha will be equal to tan inverse tau xy minus 17 by this sigma x dash 90. This is the alpha. Alpha 1, alpha, let's say alpha a, because this is third A. Again, for third B, this is the sigma x dash, tau xy dash, and resultant stress sigma r dash. We have calculated all three values putting in that formula, and here alpha b, that is the angle, that is equal to tan inverse this tau xy dash divided by sigma x dash. minus 69.28 divided by 60. That will be the answer. Again, for third question, we have sigma x dash is equal to 60, tau xy dash is equal to 69.28, and resultant stress sigma r is equal to root under sigma x dash square plus tau xy dash whole square is equal to this one. We can also calculate the alpha is equal to tan inverse 69.28 divided by that sigma x dash minus 60. So whatever the value that we'll get will be the answer. Again here sigma x dash is equal to 90, tau xy dash is equal to 17, and sigma r is equal to 91.65. So here angle alpha is equal to tan inverse tau xy divided by sigma x dash minus 90. This is the value of alpha. So here we come at the end of lecture number 3. I thank all of the students and the SEMEXCEL team for writing the slide. Thank you.